Hi, this video is going to be on balancing equations. So we're going to look at a few equations that need balancing, and I'm going to show you the method I like to use to do it. So here we've got a reaction, and we've got our reactants, which I'm going to call the left-hand side, it's barium chloride, sodium hydroxide, and we have our products, which I'm going to call the right-hand side, so barium hydroxide and sodium chloride. So if I call this the left-hand side, we're going to look at all the different atoms I've got on the left-hand side. So I've got barium, I've got chlorine, I've got sodium, I've got oxygen, I've got hydrogen. Now, the numbers of each atom I've got, because the numbers of atoms on this side have got to even the number of atoms on that side. That's what balancing an equation means. So I've got one barium, two chlorines, because the chlorine's got this little 2 after it. I've got one sodium, one oxygen, and one hydrogen. There, and there. Now on the right hand side, if this was balanced, I'd have exactly the same. And when I set it out, despite them not being in the same order, I'm going to put them in the same order as I've got them over here. And I've got one barium, I've got one chlorine, one sodium. Now this OH in brackets with a 2 means I've got 2 of everything in there, 2 hydroxide ions essentially. Means I've got 2 oxygens and 2 hydrogens. So we can see this isn't balanced because these numbers aren't the same on either side. So the bariums are balanced, so I don't need to worry about the bariums. I can start with the chlorines then. And to get the chlorines even, I need to double this, get it up to 2. So to do that, I'm going to put a 2 in front of where the chlorine is. Now I couldn't put a 2 in the middle because that will change what the structure is. Again, I couldn't put a 2 after the chlorine, a little subscript like we've got over here, because that will change what this molecule is, and I can't do that. All I can do is put 2 in front, which means I'll just get 2 sodium chlorides produced instead of 1. That changes this to 2, and also my sodium to 2. Now my bariums and chlorines are balanced. I've now unbalanced my sodiums. So I'm going to go back over and sort my sodiums out. And so 1 needs to get to 2, so I'm going to do the same thing and put a 2 in front of there. Which is going to change my sodium, but it's also going to change my oxygen. It's going to change my hydrogen, because that 2 counts for everything in the molecule. And then I can see that it's actually become now balanced. And that sometimes happens like that. Something quickly goes. So the next one, I'm going to follow the same method. And I've got C2H6, it's ethane, plus oxygen, goes to CO2 plus H2O. So I'll do my left hand side, I've got carbons, hydrogens and oxygens. Right hand side, same again. And I have 2 carbons, 6 hydrogens, 2 oxygens, 2 carbons, 6, 2. Now I've got 1 carbon, 2 hydrogens, and 2 oxygens here and 1 there, so 3. So there's a couple of things about this one. First of all, the first thing I spot is that I've got oxygen here all by itself. It's just bonded to another oxygen atom to form O2. So I'd always leave that till last, because I can get right to the end, and then whatever I need to do to oxygen, I can do it to oxygen, and it won't change, say, the carbons or the hydrogens. So no matter what, I try to leave oxygen then till last to balance. I've also, making oxygen even harder, in this side I've got both molecules containing oxygen. So if I start with oxygen and say try to balance this one, I've got my oxygens fine, but then had to try and balance my carbons, that would mess up my oxygens again. So oxygens, for a couple of reasons, I'm going to leave till last. So I'll start with the carbons. I've got 2 here and just 1 on this side, so I need to get that up to 2. Well, that's changing my oxygens now. I've got 2 times 2 here, so that's 4, and 1 there, so that's 5. Next up, I'm trying to get my hydrogen sorted, because I'm leaving my oxygens till last. And I've got to get this up to 6, so I'm going to put a 3 there. Which gets that to 6. And I'll check my oxygens again. It's often easier just to go through and count again. I've got 4 here, and now 3 here. So my oxygens are up to 7. Now, this sometimes looks like a problem, because you 2 doesn't go into 7. What you can do with this O2, and with anything that's got a 2 after it, so Cl2, Br2, I2, anything that's something 2 by itself, we can actually get a half. And then here, I'm going to get 3.5 O2s to get me up to 7. And that means my oxygen changes to 7. By leaving it till last, I could see exactly what I needed to do to that oxygen, which made it easier. I had to put a half in, which is fine, as long as that then still creates a whole number. So 3.5 times 2 gives me 7, so I'm okay there. Hydrogens are at 6, carbons at 2, and that's now balanced. Final one we'll look at is sodium hydroxide plus chlorine into sodium chlorate. That is sodium chloride and water. So in this one, it's already told me that I've got 6 sodium hydroxides. So on the left hand side, I've got 6 sodiums, 6 oxygens, 6 hydrogens, and 2 chlorines. On the right hand side, I've now got that annoying thing again where I've got sodiums in 2 molecules. So I've got 2 in total. Oxygens, I've got 3, 4, so that's annoying as well. Hydrogens, I've just got 2 over there. And then chlorines, I've got 1, 2. So I can look at this, and I always go, right, well, sodiums, because I've got 2 different molecules to get it up to 6. Could be 5 here, 1 there, 4 there, 2 here, 3 there, 3 here, 2 there, 4 there, 1 there, 5 there. I'd be guessing essentially which way it was. So I'm going to leave the sodiums. Chlorines I'm going to leave to last, but they're balanced at the moment anyway. So with any luck, they might stay balanced. Oxygens are going to be tricky because they're in 2 different molecules, and I might get one balanced, then have to change this. So instead, I'm going to look at hydrogens, because hydrogens are only in 1 molecule, and I've been given that there's 6 here, so that's kind of locked, and this is the only place it can be. I know that that 3 is the only thing that can go there to get oxygen up to 6. I couldn't do it any other way. My oxygens on this side are now 3, 6. And I know this is locked as well. This oxygen is locked. So that's fine. I know I can do nothing more to this and nothing more to that. So now I need to look at the sodiums. The chlorines are balanced. Everything's balanced so far. The sodiums aren't though. Now I can't change this. If I change this, so I start to go 5 here and get my sodiums balanced, that would change my oxygens. I've just balanced them. So I want to avoid that. And now I've got this chlorine free here. So I'm going to look at this sodium chloride there. To get up to 6, I could put a 5 there, which would make that 6. I could have done 4 there and 2 here, but that changes my oxygens as well. So I need to keep this as 1. So that has to go to 5. But that changes my chlorines. I've now got 1, 2, 3, 4, 5, 6. Sodium's now balanced, oxygens, hydrogens balanced. Just need to sort my chlorines out, so I'd put 3 there to get that up to 6. So that was a tricky one because of the multiple ones that were in this side. Try and avoid, unless you absolutely have to, solving when you've got 2 in a molecule. Leave them till later, until you absolutely have to or know some more info. And that is balancing equations.